Mars drifts through space at a gentle distance from Earth, a quiet neighbor in the vast expanse of our solar system. It moves along its path around the Sun with a slow and steady rhythm, tracing an orbit that takes nearly 2 Earth years to complete. There is something peaceful about Mars, something calm in the way it exists out there in the darkness, a small world of rust-colored dust and ancient stone, turning slowly beneath a thin and quiet sky. The planet appears red when we look at it from Earth, a soft reddish glow that has caught the attention of observers for thousands of years. This color comes from iron oxide, the same substance that forms rust here on our own planet. The surface of Mars is covered in fine dust, particles of rock that have been broken down over billions of years by the slow work of wind and temperature changes. This dust contains iron, and when that iron interacts with the small amount of oxygen in the Martian atmosphere, it oxidizes, creating that gentle red hue. The entire planet is wrapped in this rusty dust, giving it a warm appearance even though the actual temperature on Mars is quite cold. It is a world painted in shades of red and orange and tan, a desert landscape that stretches across the entire surface, quiet and still. Mars sits as the 4th planet from the Sun, just beyond Earth's orbit. If you were to travel outward from the Sun, you would pass Mercury first, then Venus, then our own Earth, and then you would arrive at Mars. It is smaller than Earth, about half the diameter, with a surface area roughly equal to all the dry land on our planet combined. Despite being smaller, Mars shares some similarities with Earth. It has polar ice caps, seasons, and a day that is just slightly longer than our own. These similarities have made Mars a subject of quiet fascination, a place that feels just distant enough to be mysterious, yet close enough to seem almost familiar. The atmosphere on Mars is very thin, much thinner than the atmosphere that surrounds Earth. It is composed mostly of carbon dioxide, with only traces of nitrogen and argon. The pressure at the surface of Mars is less than 1% of the atmospheric pressure we experience here on Earth. This thin atmosphere means that Mars cannot hold heat the way Earth does. The sky on Mars is different from our own sky. During the day, it appears a soft butterscotch color, a pale peachy tan created by the way sunlight scatters through the fine dust suspended in the air. At sunset, the sky near the Sun takes on a blue tint, the opposite of what we see on Earth. This happens because the dust particles scatter light differently than the molecules in Earth's atmosphere, allowing the shorter blue wavelengths to become visible around the setting sun. It is a gentle reversal, a quiet difference that makes Mars feel like a place apart. A day on Mars, called a sol, lasts about 24 hours and 39 minutes. This is only slightly longer than a day on Earth, a difference of less than 40 minutes. If you were standing on the surface of Mars, you would experience a day-night cycle very similar to the one we know. The sun would rise in the east and set in the west, and the hours would pass at a pace that would feel almost the same as the passage of time here at home. This similarity is comforting in a way, a reminder that even though Mars is a different world, it moves to a rhythm that is not so far removed from our own. Mars has seasons, just as Earth does, because its axis is tilted at an angle similar to Earth's tilt. The Martian axis is tilted about 25 degrees, compared to Earth's 23.5 degrees. This tilt means that as Mars orbits the Sun, different parts of the planet receive more or less sunlight at different times of the year, creating seasonal changes. However, Because a Martian year is almost twice as long as an Earth year, lasting about 687 Earth days, each season on Mars lasts much longer than the seasons we experience. Spring, summer, autumn, and winter all unfold slowly on Mars, each one stretching across many months. The seasons bring changes in temperature and in the size of the polar ice caps, which grow and shrink with the changing light. The polar ice caps on Mars are beautiful in their simplicity. They are made of water ice and frozen carbon dioxide, also known as dry ice. During the Martian winter, the temperature at the poles drops so low that carbon dioxide from the atmosphere freezes and falls as snow, adding layers to the ice caps. In the summer, the carbon dioxide sublimates, turning directly from solid to gas and returning to the atmosphere, leaving behind the water ice underneath. The water ice remains year-round, ancient and undisturbed, a permanent feature of the Martian landscape. These ice caps are bright white against the red and tan surface of the planet, visible even from great distances, quiet reminders that water exists on Mars, locked away in frozen form. The surface of Mars is marked by features that speak to a long and quiet history. There are mountains and valleys, plains and craters, each one shaped by processes that unfolded over billions of years. One of the most striking features is Olympus Mons, a massive volcano that rises about 21 kilometers above the surrounding plains. It is the tallest volcano in our entire solar system, a gentle giant that formed over millions of years as lava slowly built up layer upon layer. Olympus Mons is so large that if you were standing on its slopes, the curve of the mountain would extend beyond the horizon in every direction. The summit is broad and flat, and the slopes are gradual, rising at an angle of only a few degrees. It is a mountain built by patience, by the slow accumulation of molten rock over an almost unimaginable span of time. Another remarkable feature is Valles Marineris, a system of canyons that stretches across the Martian surface for more than 4,000 kilometers. This canyon system is so vast that it dwarfs the Grand Canyon on Earth, both in length and in depth. Some sections of Valles Marineris reach depths of 7 kilometers, with walls that rise steeply from the canyon floor. The canyons may have formed through a combination of processes, including the stretching and cracking of the planet's crust and the slow erosion caused by ancient water flows. Looking at Valles Marineris from above, you would see a long scar across the face of Mars, a network of deep trenches and towering cliffs, all carved into the rust-colored rock. It is a quiet and dramatic landscape, a testament to the forces that have shaped Mars over the ages. The surface of Mars is also covered with countless impact craters, the result of meteorites striking the planet over billions of years. These craters come in all sizes, from small pits just a few meters across to enormous basins hundreds of kilometers wide. Because Mars has a thin atmosphere, meteorites can reach the surface more easily than they can on Earth, where most burn up before impact. The craters have been slowly worn down by wind and dust, their edges softening over time, but they remain as markers of the planet's ancient past. Each crater tells a story of collision and impact, of space debris meeting solid ground, events that happened so long ago that they are now part of the quiet, unchanging landscape. Dust is everywhere on Mars. The entire planet is covered in a fine layer of it, particles so small that they can remain suspended in the atmosphere for long periods. This dust gives Mars its color, but it also plays an active role in shaping the planet's weather. Sometimes, winds on Mars pick up this dust and carry it across the surface, creating dust storms. These storms can be small and localized, or they can grow to cover large areas, even the entire planet. When a global dust storm occurs, the sky darkens, and the surface becomes obscured beneath a thick haze of airborne particles. The storms are not violent in the way we might imagine. The winds on Mars, though fast, are not strong enough to knock things over because the atmosphere is so thin. Instead, the dust simply drifts and swirls, moved by gentle currents of air, creating a soft veil that can last for weeks or even months before gradually settling back to the ground. These storms are part of the rhythm of Mars, seasonal events that come and go, reminding us that even a quiet planet is not entirely still. Mars has two small moons, Phobos and Deimos, that orbit close to the planet. Both moons are irregularly shaped, more like lumpy potatoes than perfect spheres, and both are thought to be captured asteroids, pulled into orbit by Mars's gravity long ago. Phobos is the larger of the two, measuring about 22 kilometers across at its widest point. It orbits very close to Mars, completing an orbit in just over 7 hours. Because it orbits so quickly, Phobos rises in the west and sets in the east, the opposite of what we see with our own moon. Deimos is smaller, about 12 kilometers across, and orbits farther from Mars, taking about 30 hours to complete one orbit. Both moons are covered in a layer of dust and are heavily cratered, ancient and unchanging, silent companions to the red planet. From the surface of Mars, these moons would appear as small points of light moving across the sky. Phobos would race overhead, crossing from one horizon to the other in just a few hours, while Deimos would move more slowly, taking its time as it drifted through the Martian night. Neither moon is large enough or bright enough to illuminate the surface the way our own moon lights up Earth's nighttime landscape. They are simply there, small and distant, quiet witnesses to the slow passage of time on Mars. There is evidence that water once flowed on the surface of Mars. Channels and valleys that look like ancient riverbeds wind across the landscape, and some regions show features that resemble dried-up lake beds. These landforms suggest that billions of years ago, Mars had a thicker atmosphere and a warmer climate, conditions that could have allowed liquid water to exist on the surface. Over time, Mars lost most of its atmosphere, and the water either evaporated into space or became locked in ice beneath the surface and at the poles. Today, Mars is cold and dry, a desert world where liquid water cannot exist on the surface because the atmospheric pressure is too low. But the traces remain, carved into the rock, a record of a time when Mars may have been a very different place. Scientists have sent robotic explorers to Mars to study its surface and search for signs of past life. These rovers move slowly across the Martian landscape, guided by instructions sent from Earth. They travel at a careful pace, often covering only a few meters in a day, pausing to examine rocks and soil, drilling small samples, and capturing images of the terrain. The rovers are powered by solar panels or nuclear batteries, and they operate in a harsh environment where temperatures can drop far below freezing at night. Despite these challenges, they continue their work, sending data back to Earth that helps us understand what Mars is like and what it may have been like in the past. One of the rovers, named Curiosity, has been exploring a region called Gale Crater, a large impact basin that may have once held a lake. The rover has found minerals that form in the presence of water, as well as organic molecules, the building blocks of life. These discoveries do not prove that life existed on Mars, but they show that the planet once had conditions that could have supported microbial life if it ever developed. Another rover, Perseverance, is exploring Jezero Crater, another site that may have held water long ago. It is collecting samples of rock and soil that may one day be returned to Earth for detailed study. These missions are quiet and patient, unfolding over years and even decades, a slow and careful search for answers to questions about Mars's past. The idea of life on Mars has been a subject of gentle curiosity for many years. While no definitive evidence of past or present life has been found, the possibility remains open. Mars has all the basic ingredients that life as we know it requires: water, carbon-based molecules, and energy from the sun. Whether these ingredients ever came together to create living organisms is still unknown. The search continues in a calm and methodical way, with each new discovery adding another small piece to the puzzle. Mars is a world of stillness and silence. There are no oceans to create the sound of waves, no forests rustling in the wind, no rain falling on the surface. The wind blows across the dust, but the thin atmosphere means that even the strongest winds are quiet, creating only a soft whisper as they move particles of sand from one place to another. The sky is often clear, with only occasional clouds made of water ice or carbon dioxide drifting high in the atmosphere. At night, the temperature drops sharply, and the surface becomes even colder, the heat radiating away into the darkness of space. It is a cold and lonely place, a world where time moves slowly and change comes gradually, measured not in days or years but in eons. The soil on Mars, called regolith, is made of fine particles of rock and dust. It is dry and powdery, lacking the organic matter that makes Earth's soil rich and fertile. The color of the regolith varies from place to place, depending on the minerals present, but it is mostly shades of red, orange, and brown. In some areas, the surface is covered with small pebbles and larger rocks, scattered across the landscape like pieces of a puzzle. In other places, the ground is smooth and flat, stretching out to the horizon in an unbroken expanse of dust. The landscape is quiet and empty, a vast desert that has remained largely unchanged for millions of years. The gravity on Mars is weaker than the gravity on Earth, about 38% of what we experience here. If you could stand on the surface of Mars, you would feel lighter, as if a weight had been lifted from your shoulders. A person who weighs 100 pounds on Earth would weigh only 38 pounds on Mars. This lower gravity would make it easier to jump and move around, though the thin atmosphere and cold temperatures would present other challenges. It is a small detail, but one that adds to the sense of Mars as a place that is similar to Earth in some ways, yet fundamentally different in others. The soil on Mars contains perchlorates, chemical compounds that are toxic to most forms of life as we know it. These perchlorates are present in the dust and would pose a challenge to any future human explorers. However, they also have potential uses, as they could be processed to extract oxygen or used in chemical reactions to produce other useful materials. Mars is a place that would require careful planning and preparation to visit, but the presence of resources like water ice and minerals suggests that it is not entirely inhospitable. It is a harsh environment, but not an impossible one. The sky on Mars is darker than the sky on Earth, even during the day, because the atmosphere is so thin. There is less air to scatter sunlight, so the sky has a muted quality, a soft glow rather than the bright blue we are used to. At night, the stars would be clearly visible, sharp and bright against the darkness. The Milky Way would stretch across the sky, a river of light made up of countless stars, and the planets would appear as steady points of light, unblinking in the stillness. Earth would be visible from Mars, a small blue dot in the distance, a reminder of home. The Martian landscape is shaped by the slow work of wind and temperature. Because there is no rain and very little water, erosion happens differently on Mars than it does on Earth. The wind carries dust and sand, slowly wearing down rocks and cliffs over millions of years. Temperature changes cause rocks to expand and contract, creating cracks that gradually widen over time. These processes are slow and gentle, unfolding at a pace that is almost imperceptible, but over the vast stretches of geologic time, they reshape the surface in significant ways. There are regions on Mars where the ground is covered with dark streaks that change with the seasons. These streaks, called recurring slope lineae, appear on steep slopes during the warmer months and fade during the colder months. Scientists are still studying what causes these streaks, but one possibility is that they are created by small amounts of briny water flowing down the slopes. Salt dissolved in the water could lower its freezing point, allowing it to remain liquid even in the cold Martian environment. If this is the case, it would mean that liquid water still exists on Mars, at least in small amounts and under specific conditions. It is a quiet mystery, one that continues to be explored through careful observation and analysis. The history of Mars is written in its surface. The heavily cratered southern highlands are some of the oldest terrain on the planet, dating back billions of years to a time when the solar system was still young and impacts were common. The northern lowlands are smoother and younger, with fewer craters and a different composition. This contrast between the two hemispheres is one of the many features that make Mars an interesting subject of study. Why are the two halves of the planet so different? What processes created this division? These are questions that scientists continue to explore, piecing together the story of Mars one observation at a time. Mars has no magnetic field, or at least no global magnetic field like the one that surrounds Earth. This means that the solar wind, a stream of charged particles flowing from the Sun, can interact directly with the Martian atmosphere. Over billions of years, this interaction has stripped away much of the atmosphere, causing it to become as thin as it is today. Some regions of Mars do have localized magnetic fields, remnants of an ancient global field that may have existed long ago. These patches of magnetism are like fossils, traces of a time when Mars was more geologically active, with a molten core that generated a protective magnetic shield. The question of whether humans will one day visit Mars is one that has been discussed for many years. The journey to Mars would take several months, and travelers would face challenges including radiation exposure, the psychological effects of isolation, and the need to carry or produce all the food, water, and oxygen they would need. Once on the surface, they would need to deal with the cold, the low atmospheric pressure, and the dust. Despite these challenges, Mars remains the most accessible planet beyond Earth, the most likely destination for future human exploration. It is a goal that requires patience, planning, and a willingness to accept the risks that come with venturing into the unknown. The surface of Mars is dotted with rocks and boulders, some smooth and rounded, others jagged and angular. These rocks are made of basalt, a type of volcanic rock that is common on Mars and on Earth. Some of the rocks on Mars contain minerals that provide clues about the planet's past. For example, hematite, a mineral that often forms in the presence of water, has been found in several locations. Clay minerals, which also form in wet conditions, have been identified as well. These findings suggest that water played a role in shaping Mars's surface, altering the minerals and creating deposits that remain to this day. The days and nights on Mars follow a gentle rhythm. The sun rises, the temperature slowly increases, and the surface warms under the thin sunlight. As the day progresses, the wind may pick up, stirring the dust and creating small swirls that drift across the landscape. In the afternoon, the temperature reaches its peak, though even at the warmest times, it remains far below what we would consider comfortable. As the sun sets, the temperature drops quickly, and the cold of night settles over the land. The stars come out, and the sky becomes dark and clear. This cycle repeats day after day, season after season, year after year, a slow and steady progression of time. The exploration of Mars has been carried out by orbiters, landers, and rovers, each one contributing to our understanding of the planet. Orbiters circle Mars from above, mapping the surface and studying the atmosphere. Landers touch down in specific locations and remain there, conducting experiments and sending back data. Rovers move across the surface, traveling from place to place, examining rocks, drilling samples, and capturing images. Together, these missions have revealed a world that is complex and varied, a planet with a rich history and many secrets still waiting to be uncovered. The dust on Mars is fine, almost like talcum powder, and it clings to everything. The rovers that have explored the surface become coated in this dust, their solar panels and instruments gradually accumulating a layer of red particles. Occasionally, a gust of wind will blow some of the dust away, a fortunate event that helps keep the solar panels clean and allows the rovers to continue generating power. This dust is part of the Martian environment, a constant presence that shapes the landscape and affects the equipment that operates there. The idea of terraforming Mars, of changing its atmosphere and climate to make it more Earth-like, has been proposed as a distant possibility. Such a project would require enormous resources and would take centuries or even millennia to accomplish. It would involve thickening the atmosphere, warming the planet, and possibly introducing liquid water to the surface. Whether this is something that should be done, or even can be done, is a question that remains open. For now, Mars exists as it is, a cold and quiet world, unchanged by human hands, a place that holds both the memories of its past and the potential for future exploration. The rocks on Mars tell stories of ancient volcanic eruptions, of meteorite impacts, of wind and water shaping the surface over unimaginable spans of time. Each rock is a small piece of the planet's history, a fragment of the larger narrative that scientists are working to understand. By studying these rocks, we learn about the processes that have shaped Mars, the conditions that existed billions of years ago, and the changes that have occurred since. It is a slow process, this piecing together of the past, but it is one that brings us closer to understanding not just Mars, but also the broader history of our solar system. The seasons on Mars bring subtle changes. In the spring, carbon dioxide ice at the poles begins to sublimate, and the ice cap shrinks. In the summer, the temperatures rise, and dust storms become more common. In the autumn, the temperatures begin to drop, and in the winter, the ice caps grow again, accumulating layers of frozen carbon dioxide. These seasonal shifts are gentle and gradual, unfolding over many months, part of the quiet rhythm of the Martian year. The valleys and channels that crisscross the Martian surface are reminders of a time when water may have flowed freely. Some of these features are broad and shallow, while others are deep and narrow. They wind across the landscape, following the contours of the terrain, cutting through highlands and plains. The fact that they exist suggests that Mars once had a more active hydrological cycle, with water flowing across the surface, carving channels, and depositing sediment. What happened to that water, and why Mars lost its ability to sustain liquid water on the surface, are questions that scientists continue to explore. There is a quietness to Mars that is difficult to describe. It is a world where nothing grows, where no animals move, where the only sounds are the whisper of wind and the occasional groan of rocks expanding and contracting with temperature changes. It is a place of stillness, where the passage of time is marked not by the changing of seasons in any dramatic way, but by the slow accumulation of dust, the gradual erosion of rocks, and the imperceptible shifting of the landscape. It is a world that invites contemplation, a place that seems to exist outside the rush and noise of everyday life. The ancient lava flows on Mars have solidified into vast plains of basalt, flat expanses of rock that stretch for hundreds of kilometers. These plains are smooth in some places and rough in others, the surface shaped by the way the lava cooled and hardened. In some areas, you can still see the flow patterns, lines, and ridges that mark the direction the molten rock moved before it froze in place. These lava fields are a testament to a time when Mars was geologically active, when volcanoes erupted and reshaped the surface with rivers of molten stone. The thin atmosphere of Mars means that heat escapes quickly into space. During the day, the surface can warm up to temperatures that are almost comfortable, close to room temperature in some locations. But as soon as the sun sets, the heat radiates away, and the temperature plummets. The difference between day and night temperatures can be dramatic, sometimes exceeding 100 degrees. This rapid cooling is a result of the lack of atmospheric insulation, the absence of a thick blanket of air to trap and hold the warmth. The exploration of Mars is a slow and careful endeavor. Each mission is planned in detail, with scientists and engineers working together to design instruments, choose landing sites, and create plans for what the spacecraft will do once it arrives. The journey to Mars takes months, and once a spacecraft arrives, it must operate in a remote and challenging environment with limited ability to receive instructions or repair itself. Despite these challenges, the missions have been remarkably successful, providing a wealth of information about Mars and changing our understanding of the planet in profound ways. The moons of Mars, Phobos and Deimos, are thought to be made of the same kind of material as certain types of asteroids found in the outer solar system. They are dark, covered in a layer of dust and ice, and heavily cratered from billions of years of impacts. Phobos orbits so close to Mars that tidal forces are gradually pulling it closer to the planet. In several million years, Phobos will either crash into Mars or be torn apart by tidal stress, forming a ring of debris around the planet. It is a slow process, happening on a timescale that is difficult for us to comprehend, but it is part of the ongoing evolution of the Martian system. Mars is a reminder of the diversity of worlds in our solar system. Each planet is different, shaped by its own unique history and subject to its own set of conditions. Mars is neither the hottest nor the coldest, neither the largest nor the smallest. It is a middle world, a place that shares some characteristics with Earth but is ultimately its own distinct entity. It is a world that invites exploration, a place that holds clues to the history of our solar system and perhaps to the question of whether life exists beyond Earth. As you think about Mars, imagine a quiet desert landscape stretching out in all directions, a place of red dust and ancient stone, where the sky is a soft peachy color and the wind blows gently across the surface. Imagine standing on that surface, feeling the lighter gravity, seeing the distant sun hanging in the sky, watching the small moons drift overhead. It is a place of solitude and stillness, a world that has been there for billions of years and will continue to be there for billions more, turning slowly in the darkness of space, a quiet neighbor to our own blue planet. And now, as you let these thoughts settle, allow yourself to drift into rest. The quiet landscape of Mars remains, unchanging and patient, a distant world under a butterscotch sky. Let the stillness of that place carry you gently into sleep, where the mind can wander freely and peacefully through the calm expanse of space and time.